So basically Newton's law of law for force and gravity diagram. Okay, so let's start. First thing is that first law, Newton's law of motion, and gives the first law of Newton's law basically gives the idea about force and inertia. Okay, so what is force and what is inertia? So first thing is that if we try to define the force, keep in mind that the motion of an object. So if we consider the object, there is an object on a surface. So this is a box. Okay, and this object is in a surface. Then initially there is no movement of the subject, no motion. So you can say v equal to 0. Okay. Now if we try to produce a motion of that object, or if we try to produce a velocity either rightward or leftward, we have to apply some force. So there will be certain velocity, okay, certain velocity, and this velocity is basically produce acceleration. Okay, velocity is produced because initially velocity is 0, then there will be a velocity, so velocity is changing, so the velocity change gives the acceleration. So the thing is that the quantity which produce the motion, or which produce the velocity, which change the velocity of an object, or which produce the acceleration, is called the force. So basically the quantity which produce the acceleration or change the velocity of an object is called the force. Now the thing is that if we applied some force on an object, we applied some force either rightward direction or leftward direction, or making an angle. In that case, there will be a resistance produced by the object, okay, to move the object. So we need to produce a certain amount of force to move the object. So the resistance, which basically produce due to applied force, is called the inertia. Okay. Okay. Inertia basically. Okay. So inertia and force are related to each other. Okay. If initially the object is stationary state, then in that case there is no inertia. But when we applied some force, then the object resists that force. Okay. And this resistance of that object is called the inertia. And if we overcome this inertia, then the object will move in a particular direction. Okay, so that's why force and inertia is each other. So Newton's first law is about that thing. Newton's first law. So Newton's first law states that if an object is in stationary state or in a stable form, then it will remain in stationary state or stable form, or if the object is moving in a constant velocity, that it will move with constant velocity if there is no external forces applied. So say the object is in that surface, okay, here initially velocity is 0. So if we applied no force, then the velocity of that object remain 0. The object will remain stationary state at that point. Okay. Now another thing is that if we consider the object is moving with velocity like that, v equal to say 5 meters per second. Okay, 5 meters per second. And if we consider the surface is frictionless, then in that case the object will move same velocity. Okay, the velocity will remain same, 5 meters per second, if there is no external forces applied. But if we apply a force at that direction, then velocity will increase if we apply velocity force at that direction, velocity will decrease if the velocity is rightward direction. Okay, and another thing is that if the surface is frictional surface, there is if there is friction involved in that surface, in that case, velocity will change because there is a force involved which is called frictional force. Okay, so this is the first law. Mainly, first law describe the force and inertia. Okay, so this is all about the first law of Newton's law. And second law, Newton's second law. So Newton's second law state that the rate of change of momentum. So momentum, what is momentum? Okay. Momentum. So momentum is basically multiplication of mass and velocity of an object. So mv or mu. Okay, so this, if you consider initial velocity u, then mu, and if you consider final velocity v, then mv. These are the main momentum. Okay, so multiplication of mass and velocity gives the momentum. Okay. Okay, so this is the momentum. The question is the rate of no, sorry, the statement is the rate of change of momentum. Rate of change of momentum. So rate of change means the del mv by del t. Rate of change of momentum is proportional to applied force, and mainly action is happening in the direction of the applied force. Okay, so del mb by del t is proportional to F, then we can say m is, if we take m common, then del b by del t, because mass is not changing, because mass is constant, is equal to, there is a proportionality constant k F. So here k is 1. Basically, if we calculate the values, k will be 1, and we can say m del v by del t is basically acceleration. We know that del v by del t is equal to del v by del t is equal to acceleration, and if k is equal to 1, we can say F equal to ma. Okay, F equal to ma. And finally, let's say F equal to ma. So this is the final equation, or mainly the equation for second law, Newton's second law. Okay. Okay, just wait for one. So Newton's second law is basically F equal to ma. So if we consider the two-dimensional case, in case of two-dimensional case, because we know that, can you hear me? Just confirm when you are. Can you hear me?
Yes, sir.
Okay. Okay. So force is a vector quantity and acceleration is also a vector quantity, then you can write down the equation like that. If vector is equal to m vector a, okay, so this is the equation. Now in component form, you can say, if consider the if x is equal to mx and if y is equal to m ay. So this is really the equation for on the x-axis, and this is the equation for y-axis. And another thing is that if more than one force is involved, then we can write down the equation like that. If net force is equal to ma, if net force is equal to ma, in that case, on the x-axis, if net force on the x-axis is equal to max, and if net force on the y-axis is equal to may. So these are the formulas, or mainly the topics covered in second lecture video. And in case of third lecture video, we just will learn about the free body diagram. How can we solve mathematical problem using the free body diagram, or using second law of motion, using the second law of motion. Okay. Okay. So this Newton's second law is basically equal to ma. Now let's solve a problem. Say there is an object here, okay, and we applied a force along that direction is 12 Newton, okay, and due to this applied force, if you consider the mass of this object is 3 kg, okay, 3 kg, okay, then in that case we can say F equal to ma, then you can easily find out the acceleration by equation F by m. This is 12 meter per second square. So this is the acceleration produced due to applied force 12 Newton on 3 kg object. Now if we consider another force is involved like that, say the force direction, and that angle is theta, which is 30 degree, okay, and force is say 10 Newton. So in that case, we have to draw a free body diagram like that. We have to consider this x-axis and this is y-axis. Okay, this is x-axis, this is y-axis, and the object is in origin. Okay, then we have to draw the component of this force. Okay, and here 12 Newton force is applied along that direction. Okay, this is the 12 Newton force. Okay, and we know that the vector cannot be drawn like that. Okay, we have to draw the vector, keep the tail in the origin. So that's why 10 Newton force is basically applied like that. This is the 10 Newton force, and if this angle is theta, then we can say this angle is also theta. Okay, this angle is theta. So if this angle is theta, then we can say this angle is theta. So that's why 10 Newton force is drawn like that. Okay, and if we try to draw the component along that axis is 10 cos theta, and along that axis is 10 sin theta. Okay, so because we know that if the vector is a, then this vector has two components. Along the x-axis is a cos theta, and along the y-axis is a sin theta. Okay, now let's write down the Newton's second law, which is F net force along the x-axis is equal to max. Okay, now net force along the x-axis, there is two force involved along the x-axis. One is 12 Newton, another is 10 cos theta, and 12 Newton is in the positive direction, and 10 cos theta is in the negative direction. So that's why we can write down 12 positive and 10 cos theta negative. So 10 cos 30 degree. Theta is given 30 degree, and the mass is, if a mass is given, if m equal to 3 kg, m equal to 3 kg, then 3 a. Basically here acceleration is along the x-axis, and along the y-axis acceleration is 0 because there is no movement along the y-axis. This object is moving along the x-axis because this is the surface. Okay, the object is in x surface, but there is a y component of force, so that's why we are drawing the y component, but the acceleration on the y component is 0. Okay, so then from that equation you can easily find out the acceleration along the x-axis. And another thing is that here a new force is involved in that case, which is called reaction force. Reaction force or normal force. Okay, reaction force or normal force, which is always involved if the object is in surface. If the object is in surface, so the object is in surface, that's why surface will give a force and the opposite direction, which is according to the Newton third law. Newton third law states that if there is an action, there is an equal and opposite reaction. So that's why the object weight is downward and there is a normal force upward direction, which is denoted by n. And another thing is that weight is always downward. So there is a force weight involved in downward. So here forces are weight, normal force, 12 Newton force lightward, and 10 Newton force produce an angle with negative x-axis. Okay? Then if the forces are given in given in an angle with particular axis, we have to draw the component. Okay, so then we can write down the y component of the forces are like that. Positive is on the positive y direction, forces are n, and on the negative y direction, forces are w minus 10 sine theta or 10 sine 30 degree. So here W and 10 sine 30 degrees forces are negative because they are acting along the negative y-axis, and normal force is acting right upward direction, which is positive y-axis. This is the net force. This force is basically net force along the y-axis, and this is equal to m a y. So F equal to ma. Basically, this is the Newton's second law, and here ay is 0 because there is no acceleration on the y-axis. Okay, then you can find out the normal force from that equation. Normal force equal to W plus 10 sine 30 degree. Okay, so weight is equal to mg. We know that weight is mainly acceleration due to gravity, force involved due to acceleration due to gravity. This is mg 10 sine 30 degree, and from that equation we can easily find out the normal forces. Okay, so this is the procedure to solve a problem by using free body diagram, and this diagram is called free body diagram. Let's talk about the forces involved in this chapter, in these topics basically. So forces are weight, this is mg, normal force or normal reaction force, which is n, and tension, okay, so tension, this is T, and applied force, applied force is mainly F, any kind of external force or applied force. And weight is always present in an object because the mass, if you consider mass is m, then weight is downward, which is mg. And normal force is involved when particular object is in surface. If the object is in a surface, then the force involved, the reaction force, normal reaction force is upward direction, and weight is downward. Okay, and tension, basically tension involved when the object is attached with a string like that to suspend the object, or if we just add a mainly string or particular thing with this object. Okay, then the force away from this object, basically, so along that direction, in that direction, and that direction. Okay, so suspended point or tension involved in case of away from the object is called the tension. Okay, so say the object is in a table, and if we take a pulley, okay, and if we attach two objects like that, okay, so in this case, the tension for that object is along that direction and that direction. This is, if you consider, this is T1, this is T2. Okay, and for that object, the tension upward, and this T1 and tension T1 and T1 equal, and for that object, T2 is upward. Okay, basically away from the object. So for that object is upward because away from that object, and for that object, but this T2 and T1 not equal, okay, due to the different weight attached with that object. Okay, so these are the tension, and applied force is normal applied force. Say if we force applied like that or like that, okay, or like that. Okay, so these are the applied forces. So these are the forces involved in free body diagram, and the drawing of free body diagram procedure basically. Okay? So first we have to draw the x-axis and y-axis. So let's talk about an example. Say this is an inclined plane, okay, and certain object is here. Okay, certain object is here, and if we apply a force like that to try to move the object upward direction with angle theta, then in that case we have to consider the surface, this surface, as an x-axis. Okay, so if you consider this surface as an x-axis, then perpendicular this surface you can write to y-axis. Okay? This is the object. Now here we know that normal force is always involved if the object is in a surface here. Okay, and if you consider the weight is always downward, so weight W, if this angle is theta, okay, this angle is also theta. Now the applied force is like that, force F. So we consider this is theta 1, this angle is theta. Okay, now tension is not involved because there is no attached spring here. Okay, so that's no tension is involved. Now we can say the component of this force is F cos theta, and along the upward direction is F sin theta, and for the weight, and that direction is W cos theta, and along that direction is W sin theta. So this is the free body diagram. The process is, first we have to draw the x-axis and y-axis. So always we consider the surface where the object state is considered the x-axis, and the y-axis is perpendicular to this x-axis. Okay, and then we have to draw the forces, individual forces. Then if the forces produce a certain angle, then we have to draw the component of these forces. And finally, write down the F net force x-axis is equal to max, and F net force along the y-axis is considered as a AY. Okay, so here F net force is F cos theta and W sin theta. So F cos theta minus W sin theta, and net force along the y-axis, three forces are involved. We can say N plus F sin theta minus W cos theta. Okay, so this is the net force along the y-axis. Okay, so these are the procedure to draw the Fibonacci diagrams. And in case of cushion will be like that. Say the object is moving. This is theta. Okay, object is moving downward direction. Okay, downward direction, and if we try to apply the force like that, apply the force in that direction, and also to try to move the object upward direction, and in that case, first question will be like that. Draw the Fibonacci diagram. Draw the Fibonacci diagram. Second question will be like that. Find the acceleration. And third question will be like that. Find the normal reaction force. Okay. So if you draw the Fibonacci diagram first, then you can easily answer this part and this part, because after drawing the Fibonacci diagram, you have to apply the Newton's second law formula along the x-axis and along the y-axis. If you apply the Newton's second law on x-axis, you will get the acceleration, and if you apply the Newton's second law along the y-axis, you will get the normal reaction force. And all of the informations will be given in the question. Okay, say force F given, normal force, weight given, normal reaction force given. Okay, so this is the procedure. How can we solve the problem related Fibonacci diagram? Okay. Now, do you have any question regarding these topics? Basically, these are the topics covered in second and third part of lecture 2, week 2. Okay.
Sir, how are we going to draw the diagram? Like, will you accept the handwritten one?
Yes. Basically, we will take exam. If we take exam or assignment, you have to show the mainly the handwritten part, taking picture, then you have to convert it into PDF file, and then if you send the PDF file, I will check them. Okay.
Sir, have you checked your quiz scripts?
Mainly graded quiz is automatically graded, so I can mainly show you the result after the quiz. Okay, so this is automatically graded quiz. I will upload the result. Okay, in slide. Okay.